Hello everyone, I am Girish P from Sri Venkateshwara College of Engineering. Today we will discussing about the topic moment area method and conjugate beam method. Moment area and conjugate beam method. In this presentation, we will explore the fundamental principles of the moment area and conjugate beam method for structural analysis and designs. First, moment of area. The first moment of area is the important concept for understanding how axial loads affect the beam's deflection. By calculating the centroid of the section, we can find the point about which the sum of moment of all the forces acting on the beam. Centroid. The centroid of the geometric center of a beam cross-section defined as the area weighted average of all the points in the section. Moment of force. The first moment of area that can be found by taking the moment of all the forces about it centroid to the section. Second moment of area. The second moment of area is a measure of the beam's resistance to bending by calculating the moment of inertia about a given axis. We can determine the beam's stiffness and deflection under loads. Definition of moment of area. The moment of inertia is a measuring of a beam's resistance to bending, defined as the sum of all infinitesimal cross-sectional area times their squared distance for a given axis. Shape factor. The shape factor is the ratio of the second moment of area about any axis of the second moment of area about the centroid axis. Equation. The equations for calculating the second moment of area have basic shapes as well known as easily found. Slope and deflection equation. Using the moment area and conjugate beam method, we can derive equation for the slope and deflection of a beam under load. This equation provide critical information on designing and analytic structures. First, slope equation. The slope of a beam at any point that can be calculating by integrating the shear force over the length of the beam. Deflection equation. The deflection of a beam at any point can be calculating by integrating the moment area of length of the beam. Boundary condition. The slope and deflection equation are only valid under certain boundaries conditions such as pinned or fixed supports. Applications in beams and frames. The moment area and conjugate beam method finding widespread application in civil and mechanical engineering, especially in the design and analysis of beams and frames. Beam analysis. The moment area and conjugate beam method are particularly useful for analyzing beams with complex loading such as point load and bending moment. Frame analysis. The moment area and conjugate beam method can also be applied to the analytic of frames, allowing engineering to determine the internal form and deflection to complex structures. Comparison of moment area and conjugate beam method. The moment area and conjugate beam method are both valuable tools for structural analysis and design, but they have different strengths and weaknesses. Moment area method works well for symmetrical loading, requires integration for curved beams, providing insight into the distribution of bending moment and shear force. Conjugate beam method works well for asymmetric loading requires differentiation for non-uniform loads, providing insight into the distribution of shear force and deflections. Next, conclusion. The moment area and conjugate beam method are powerful tools for understanding the behavior of structures under load. Further research the development in this area will enhance our ability to design and build structures that are safe, efficient and sustainable. Thank you for watching.